In this lesson, we're going to continue with a note on integers and powers. The last lesson I did integers, and now I'm just going to finish this one off and work on the part to do with powers. So again, this is something that I assume that you know, that you've at least seen before, but I'm going to review it from scratch. So a power is, it's if you have the base and the exponent together. So this whole thing here is a power. 8 to the exponent 2 is the power. And as you can see, there's two parts in a power. There's the base, which in this example is the number 8, and there's the exponent, which in this case is the number 2. So if I'm using the terminology correctly, then when I talk about a power, I'm talking about the whole thing. When I'm talking about an exponent, I'm just talking about the little number up at the top. And an exponent is a number of a number, says how many times to use that number in a multiplication. So it's not saying 8 to the exponent 2 is not saying 8 times 2. That's what people sometimes get confused about. What it's saying is 8 times itself 2 times, so 8 times 8. As you can see down here, 8 to the exponent 2 means the same as 8 times 8, which actually equals 64. People, again, who are not quite getting it yet would think that 8 times 2, or 8 to the exponent 2, is equal to 16. But again, it's just whatever the base is, it's multiplied by itself that many times. In words, 8 to the 2 could be called 8 to the power 2. I wouldn't say that. Actually, I'm going to erase that. I don't like that. I'm going to say 8 to the exponent 2. I mean, of course, you could say here 8 to the power 2, but I'll never use that. So 8 to the exponent 2, kind of squeeze that in there, or 8 to the second power, or simply 8 squared. Yes, if it's the exponent 2, then it would be 8 squared. Exponents are also called powers or indices. Again, I just pointed out that exponents and powers are not the same thing, though they're related. Indices may be a term that is correct, but it's a term that I don't think I've ever used, so I don't imagine I'm going to likely use it in the near future. But if you come across it, sure, why not? Here's some more examples. 5 to the exponent 3, or 5 to the 3, as I'd say for short, means 5 times itself 3 times. 5 times 5 times 5. 5 times 5 is 25, times 5 again equals 125. In words, 5 to the 3 could be called 5 to the third power, or 5 to the power 3, sure, or simply 5 cubed. So we've seen up above that if we have an exponent 2, we usually call it squared for short. If we have an exponent 3, we call it cubed. And we don't really have anything beyond cubed, though. So, for example, if I have 2 to the 4, then that means 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, so that's how that works out. But we could call it 2 to the 4th power, 2 to the power 4, or simply 2 to the 4th. Notice how we don't have a cubed or squared word for that one. Exponents make it easier to write and use many multiplications. So, for example, 9 to the 6 is easier to write than 9 times 9 times 9 times 9 times 9 times 9, right? It's a short form in a certain way. You can multiply any number by itself as many times as you want using exponents. So in general, a to the n tells you to multiply a by itself a certain number of times, n times. There's n of those a's. So a to the exponent n, a is the base, it's going to be multiplied together n times. Again, it's not a times n, it's a times itself n times. Another way of writing it, sometimes people use this little symbol here. I think technically it's called a caret, not like the vegetable. I think it's written like this. and it's just this little symbol here, and you can find it on your keyboard. Often it's above the number 6 if you're typing things out, and so it's easy to type. So this here also means 2 to the 4, 2 to the exponent 4, and it means 2 times 2 times 2. I think I said that 4 times, which equals 16. So if we calculate the following, well, we can do it on our calculator, or we can just understand it. I think it's best to understand it for now. Calculators are great things, but we don't want to be reaching for them when we don't need to. It's good to rely on the calculator in our skull whenever possible. That way we'll make it stronger. So we need to understand that 2 to the 3 means 2 times 2 times 2. Remember, that could also be called 2 cubed. 2 times 2 is 4, and 4 times 2 is 8. 4 to the 2 means 4 times itself twice, right? And we know that we call that 4 squared, and 4 times 4 equals 16. And the last one here is 2 to the 5, 2 times 2 times 2 times 2 times 2. When we're dealing with 2s, we're just doubling every time, right? 2 times 2 is 4. 2 times, sorry, got distracted by this suggested commands up at the top of my iPad. Go away, you. 2 times 2 is 4. If I multiply it by 2 again, I'm doubling 4. So 4 times 2 is 8. If I multiply it by 2 again, then 8 doubled is 16. And if I multiply it by 2 one more time, I'm doubling 16, and it equals 32. In general, if you have a negative base with an exponent on it, the exponent will determine the sign of the answer. So, for example, negative a to the n will give a negative answer if the exponent is odd. So it will give a negative answer if the exponent is odd. And it'll give a positive answer if the exponent is even. So that allows us to easily evaluate the sign of the following. The 1 to the 97, negative 1 to the 97 is easy as far as the number part goes, because 1 times itself any number of times is still 1. But how we decide whether it's positive or negative is we look at this here. Again, odd or even. Well, the answer is 97 is an odd number. If it's an odd number, then it's going to be a negative answer overall. And again, it's because I'm looking at the negative sign inside the brackets. I'm looking at this negative here. So, as far as the signs go, I know it's negative, and then 1 times itself 97 times is still just 1. It's not 97. It's not 1 times 97. It's 1 times 1 times 1 times 1 times 1 times 1 times 1, etc., up until I multiply it one more time, up to the 97th time where it's still just 1. But at 1 times itself any number of times is still just 1. If the negative sign is not in a bracket with the base, then the negative is not part of the repeated multiplication. That's really important to watch out for. I'm going to underline that in red. So there's a big difference between these two things. This and this are different. Well, sorry, I was thinking it's not quite what I was expecting to say. Those two actually aren't so different. They are a bit different, but those two are actually the same. But I want to compare it to one that actually is different. This is different here. So if we have no brackets it's assumed that the minus sign is not affected by the exponent, so it's negative, and then we have 2 times 2 times 2. So we just have that one negative out front, and then 2 times 2 times 2 is 8. The same thing's going on for this one. Negative, and then we have 2 times 2 times 2. So those brackets also mean multiplication. Exact same thing. This one means something a bit different. This one means negative 2 times negative 2 times negative 2. Just to break it down into pieces, negative 2 times negative 2 is equal to positive 4. But I still have another negative 2 to multiply by. And so positive 4 times negative 2 gives me negative 8. I got the same answer for all of these, but I got at them a different way. And it'd be nice to show an example where we can see how it does make a difference. So let's just add a little other example here. What if I were to compare, say, negative 3 squared and negative 3 in brackets squared? Well, the first one again means negative 3 times 3. The negative's not affected, so the negative stays out front. And 3 times 3 is 9. Whereas this one means negative 3 times negative 3. And a negative times a negative, as we saw in the last lesson, equals a positive 9. So the brackets do make a difference in this case. And it goes back to, again, this idea of whether we have an odd exponent or an even exponent. An odd exponent, if it's on something that's negative in brackets, like this one here, an odd exponent where you got a negative inside brackets will always come out negative. An even exponent on a negative base, where the negatives inside the brackets will always come out positive, like this one I just showed here. If there's no brackets, like this one or this one, it doesn't matter whether it's an odd or even exponent because it's not affecting the negative sign. As we already talked about, the negative sign is not affected. Sorry, not sure why that shut down on me. What happens if I cancel? Things have gone funny on me. Okay, random shutdown. All right, let's take a look at 2 more examples. Expressions with variables can be evaluated by substituting the given variables into the expression. So this is the last thing we need to know. Variables like x and y can be simplified. We can do a substitution. We can do a lot of substituting in this course. So I can tell someone that if 2x plus 5 minus 3y, if x equals 4 and y equals 2, then I can replace the x with the 4 that it's equal to. I can replace the y with the 2 that it's equal to. I just use highlighting often to show that some things are the same. So I'm replacing the x with the 4, that's why I've highlighted all those in green. I'm replacing the y with the 2, that's why I highlighted all those in blue. Now, following order of operations, we're going to review order of operations in another lesson, but for now, just remember that multiplying and dividing come before adding and subtracting. So I have to multiply the 2 times 4 to get 8, and I have to multiply the negative 3 times 2 to get negative 6 before I can add that 5 in there. The multiplying has to come first. Now, as we saw, adding and subtracting integers, I'm going to go from left to right. So 8 plus 5 is 13, and then I take away 6, and I've got 7. And you could use the number line for that, or you could use the other technique we talked about. In this case, I'm going to replace x with 3, and I'm going to replace y with 5. And so my first step is just to rewrite it. So I've got 3 squared plus 4 minus 5. Notice how I use brackets to show where I'm doing substitutions. That's a good habit to get into. I recommend you do that. And again, following order of operations, I ought to do my exponents first. So 3 squared is 9, because an exponent's really just a multiplication plus 4, and then taking off those brackets, it's minus a positive 5 becomes just minus 5. 9 plus 4 is 13. Take away 5, and my final answer is 8. I usually put a circle around my answers. All right, that's it for our review of powers.